Hello, good evening, everyone. Uh, Today is day 6, and today I'm going to discuss chi-square test, right? So give me a second. Firstly, I'll go on my R and I'll share my screen, and then we will discuss that how we can perform chi-square test in R, right? So give me a second. I'm just sharing my screen. Okay, I think my screen is visible now.
Yes, ma'am.
Yes. So, as I said, today agenda is the chi-square test. But before proceeding with chi-square test, we'll talk about the inferential statistics, right? Because chi-square test is a kind of test which can be a non-parametric test, right? And which we are using for testing the hypothesis. So firstly, we will understand the term inferential statistics, right? Okay. Inferential statistics. In the last few session, I think in the last or back I think session number third or fourth, maybe probably I talked about when I was talking about the functions. I talked about the descriptive statistics, right? So we can say we can divide the statistics into the two parts: descriptive statistics and inferential statistics. Descriptive statistics we have already seen, which is used to summarize the data, to describe the data, and which descriptive statistics is the first step. It is a very basic thing which you need to perform firstly on your data, right? After that, if you want to test your hypothesis or something like that, in that case, you can talk about the inferential statistics. So inferential statistics is help or will help you to infer the population parameters using sample. So I think as almost of everyone is academician and we know this thing, that usually it happens when the population size is sufficiently large. Means population size is very large, and it is not possible for us to enumerate or to pick each and every unit of the population. In that case, what we do, we are drawing a sample from the population, right? And usually when we are writing a paper, maybe I think everyone is aware of this thing. So we are generally mentioning the sample size is 100, 200, 500 something. So that way we know this thing. Using a sample, we are trying to infer the population parameters. We are trying to ascertain the population parameters. So in that case, we are taking the help of inferential statistics, right? Now, I can say when I talk about hypothesis testing, so whatever data we will collect from the sample, using that data, we will test the hypothesis which we have formulated, and that way we will decide upon whether we are going with the null hypothesis or whether we are rejecting the null hypothesis. So let me tell you this thing. I think we all know this thing. Whenever we are talking about hypothesis testing, and whenever we are talking about testing of any particular hypothesis, we are generally testing a null hypothesis, right? So we always test null hypothesis using the various statistical tests, right? Now talking about, if I talk about statistical tests, so we need to know this thing, that in statistics there are two types of tests: parametric tests and non-parametric tests. So these are the two categories of the statistical test: parametric and non-parametric. Parametric test means the tests which consider the parameters of population and also concerned about the normal distribution of the data. In that case, we can talk about that these tests are the parametric tests. In this category, generally you can keep t-test, you can keep ANOVA, regression can also be the part of this, correlation can also be the part of this. Likewise, these are the some of these parametric tests, right? Talking about non-parametric tests, generally these tests are based on qualitative data. That is categorical data, right? And these do not consider the normal distribution of the data, right? So these are the non-parametric tests, or these are the features or the definition of the non-parametric tests. Under this category, we can keep chi-square, we can keep Mann-Whitney, U-test, we can keep Kruskal-Wallis test, we can keep Spearman's rank correlation. So these are the few of the tests which we can keep in this particular category, right? Today I am going to talk about the chi-square test. So this is the basic thing you need to know before performing these type of tests. I hope I am clear on these. Any doubt, if you want to ask me anything, or may I proceed?
Yes, ma'am. Please proceed.
Okay, fine. Talking about the agenda of the day, chi-square. So chi-square test, as I just said, chi-square tests are or is it is a non-parametric test, right? And it is based on categorical data, right? Now, further I can say it does not consider the normal distribution of the data. So this way, this can be the basic thing which we need to know, right? Now you need to know the types. So if I talk about types, I can say the first type is the chi-square goodness of fit. It is the first category of chi-square test. Second is the independence of attributes. This is the second category of chi-square test. When I talk about chi-square goodness of fit, generally this test we are using to check the uniform distribution of frequencies. As I just said, as this is a as I just said that this is a kind of non-parametric test. So non-parametric test, if I say, so this is a maybe a categorical data, maybe a nominal or the ordinal scale data. So here we need to have a count. Count means the frequencies we need to have. Whereas when we talk about the parametric test, where we are taking a there we are testing a variable which should be numeric or continuous in nature, right? So in that case, we will be having the values. Here we are having the counts. So there is a difference in counts and values, right? So once we are having a count, in that case, chi-square test is the appropriate test to perform. So when I'm saying here, when we talk about the goodness of fit, so as I said, here this test is used to check the uniform distribution of the frequencies, right? So whatever variable you will be having, whatever categorical variable you will be having, for that you need to check whether the frequencies are equally distributed along all the categories or not, right? So in this, you can write that chi-square test, the goodness of a test is, it is based on one categorical variable or attributes. I think attributes will be the better word, right? So when we talk about the chi-square goodness of fit, this is based on the one, it is based on the one categorical variable or one attributes, right? Here, if I talk about manually how to perform, why I'm talking about manually, because it is or this is imperative to understand that what is the basic or the base of getting the chi-square value, right? So here, if I talk about the chi-square test manually, I think you people are knowing this thing, that chi-square is equals to the sum of O minus E square divided by E, where O is your observed frequency and E is your expected frequency, right? Fine. Till here it is okay.
Yes, ma'am.
Fine. So again, I'm repeating, chi-square formula says sum of O minus E square divided by E, where O is the observed frequency and E is the expected frequency. Or I can say O is the observed count and E is the expected count, right? So that means here you can see the concept of chi-square. It is telling you we are expecting that the frequency distribution should be uniform. So observed means whatever data we are having, that is the observed frequency, right? Now we need to calculate the expected frequency and then we need to check throughout, means we will find the difference in these two and then we will check whether the expected count is coming similar to the observed count or not. That you need to check. And that way we will consider that the frequency distribution is uniform or not, right? So in case of chi-square goodness of fit, E is what? E is nothing but it will be the average of observed frequencies. So that way you can get the value of E, right? Now, I think till here I am fine. May I, I'm okay or clear? May I start with the example now?
Yes, ma'am.
Yes. So here I'm taking the exercise number 1. Suppose, I think I am very fond of a game that is Candy Crush. I usually try to spend some time to play that. Usually in my leisure time, I usually play that. And I think many of you have heard about this game also. This is Candy Crush game, right? It is a mobile app. Using that, we can play that particular game. So there we know there are certain colors of candies available in different colors, right? So suppose I'm taking a small case, right? Or I can say this thing, that suppose a company wants to find this thing, that which new color candy they need to introduce in this game, right? So for the purpose, suppose they have done a survey. They asked from the respondent that which color candy they need to introduce, right? So that way this is a case. So we need to see firstly whatever is the frequency count we are having, that you need to check, and then you need to check whether that observed frequency is similar to the expected frequency or not. So you need to perform there the chi-square test. We want to check whether the whatever color preferences are given by the users or maybe the persons, those who are responding to, or they are coming in, or they are taking the part in that survey. You need to check whether whatever count the company is getting, that count is equally distributed to all the colors or not. This is the main purpose behind applying the chi-square test. I hope situation is clear to everyone.
Yes, ma'am.
So may I proceed? Yes. So now I say,
The screen share is gone, ma'am.
is it okay? Just a minute. I think mistakenly again I touched. Okay. Visible now?
Yes, ma'am.
Yeah. So I was talking about the first exercise. I explained you the situation. Now we need to see whatever the expected count. Suppose I am writing here colors, right? So you need to check firstly what colors company want to launch. Suppose company is doing a survey on just doing a survey on these colors. Suppose colors are pink, yellow, white, blue, then suppose red, and suppose orange, right? These are the few colors on which the company is expecting, or a company is searching or getting or doing a survey and want to see which color candy they need to launch in that Candy Crush game, right? For the purpose, few respondents or few persons were invited for giving their color preferences, right? So suppose I am making a vector of color using a C function, and suppose I'm writing here the frequencies, right? Suppose these are the frequencies I have written, that for the pink color, 100 people said that the pink color should be launched. Yellow, 80 votes went for the yellow. For white, 95 votes. For blue, 115. For red, 120. And for orange, it's 50. Is it clear? I hope it is clear.
Yes, ma'am.
Yeah. So this way, I think I'm writing here. Above this, I'm making a comment that creating a observed frequency vector, right? Fine.
Yes, ma'am.
Fine. Now I need to calculate expected frequency, right? So expected frequency, how I can calculate?
It should be the average.
Average of
Yes.
observed.
Yes. So I need to use the mean function, right? And I need to pass inside this this, or I think I can
Color.
directly the color, right? That would be much easier, right? And if you want to see what is there in expected, it is 93.33. Fine.
Yes, ma'am.
Done. Now, you need to firstly write your hypothesis. I think I forgot to tell you, you might make your hypothesis. What will be the hypothesis? Can anyone tell me? H naught or H0? What will be the hypothesis here?
There is no association between
Hmm.
the color
Hmm.
and
Hmm.
the color of the candy and what is it? And the
Which choice?
choice of the color.
Okay. Okay. Who is speaking, ma'am?
Ma'am,
May I know the name?
Saumya.
Sorry?
Saumya.
Soumya, ma'am. Okay, fine. Good attempt, ma'am. Can anyone other, any other person tell me what will be the hypothesis here?
I don't know
Ma'am,
exactly the hypothesis, but there is definitely a relation between the colors and the whatever values have been observed, I think.
It may be also stated like there is no difference in color choices by customers or consumers.
Okay. Okay. Fine. Anyone else will attempt?
Ma'am, I think hypothesis means whether your assumption could be true
Yes.
or false.
It is an assumption only. Using the
Yeah,
data, we are testing whether the assumption is true or not.
yeah, I
So,
think so.
so
It
here,
could.
what will, in this case, what will be the hypothesis?
Uh, I guess we will take the position or color where we are going to move over color at which position.
Okay.
I guess so. I'm not so sure about it.
Okay. No issues. Fine. So as I said, we are comparing the expected and observed frequencies here, right? So the hypothesis will be there is no significant difference in observed and expected frequencies of colors. This can be the one way of writing a hypothesis, or you can write that the frequency distribution of candy colors is uniform or is not uniform, right? Yes or no?
How will we
yes,
decide that?
Which thing, sir?
You're saying whether it is uniform or not,
That the chi-square test will tell you.
is that we are going to calculate, right? Okay.
The chi-square test
So,
will tell you that we are accepting
right.
the hypothesis or rejecting the hypothesis,
Okay.
right?
Ma'am, first statement is there is no significant difference between observed and expected frequency of color.
Hmm. Yes, sir.
What does that mean actually? Like if we are given this, if we have created this vector,
Hmm.
what does that mean that there is no significant? I don't get that statement actually. Not
Sir,
understanding the problem. Yeah.
so problem is very simple. We want to see. Means company wants that company should have no dilemma. Company can decide by its own which color they want to launch, but still they want to do a survey, right? And they are taking in a survey which color has get more popularity, which color the users want to bring in the candy colors, right? They want to check this, right? So they have done a survey. In a survey, you have seen that we have made a metric, we have made a vector in that we have collected or we have written the frequencies of the colors, right? For which color the most preferences came. Is it okay?
Yeah. And then maybe okay. Then we proceed like from each color choice we subtract the mean value. Is that it?
No, 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 no. I think
Because that is the
give me a
not
second.
understanding actually what the problem
Give
is. So
me a
can you
second.
just make it clear? Yeah.
Just a minute. I'm writing there on a Word file and then I'll explain you. Chi-square goodness of fit, right?
Your screen is not shared right now.
Oh, fine, fine. Sorry, sir. Now it's visible.
Not yet.
Give me a second. Is it visible now?
Yes, it's visible now.
Yeah. So I was talking about chi-square goodness of fit, right? So here I'll take a table to make you clear the thing. I'm making a small table. O minus E square. I think it is sufficient. One extra column I have taken. I need to take only 5. See, sir, please pay attention here. I'm telling you firstly manually, right? Suppose O minus E, then suppose O minus E
Square.
square, and this is
Pi square.
O minus chi-square. I think I can rightly write, right?
Yeah,
O
yeah, you can write
minus-
that. Or divided by E.
Yeah, O minus E square divided by E. This will give you the chi-square, right? So this is the formula. This formula says, right? Give me a second. So I think we have taken few figures. Can anyone tell me what figures we have taken?
Yeah, it's 100,
Hmm?
80, 95, 115, 120, and 50. 50, 50 is the last. 120 and 50, yeah.
Yes. And we have also calculated the expected count, which is 93.3,
93.3.
right?
Yeah.
So this expected count will be same throughout all the categories of color, like this,
Yeah.
right? And then we will take the difference of O minus E, which will come here in the next column. And then
Right.
of that difference, we will square it. And the square will be divided by this expected count. And when you will sum this column will give you the sum. Sum will give you the value of chi-square. Is it fine, sir?
Okay.
This is the
Yes,
manual
ma'am.
process, right?
Yeah.
But once I talk about there in R or maybe in some other software, so process is a little different, right? So we are not going here in this particular form. We are talking about this form, right? So here I was talking about the hypothesis.
Hypothesis.
I
Yeah.
was telling you the hypothesis will be, I'm writing both the ways. So first way I'm writing, there is no significant difference in the observed and expected frequencies of candy colors, right? Is it fine? So as we are talking about statistics, right? In statistics, we were talking about the term significance, whether the difference is significance, because in maths we know 2 and 2.8 or 2.6 are not same, right? In maths it is not possible to say 2 and 2.6 are equal. But in statistics, you need to see whether that difference which is coming, that is 2 and 2.6, the difference is 0.6, whether that difference is significant or not, whether it is making impact on your decision or not. You need to pay attention when the difference coming as significant, when the difference is coming significant. In that case, that is a alarming situation. That way you need to consider the thing and you need to take a decision accordingly. But when the difference is not significant, that way you can go for any of the choices or any decision you take. Is it okay, sir?
Yes, ma'am.
Right? So here we are talking about, we need to find that the observed frequency count and expected frequency count is similar, or is there any significant difference existing. So that is why in statistics there is a meaning of significant. But when I talk about maths, in maths we are only say 2 and 2.6 are not equal. But in statistics we are checking whether the difference which is existing between 2 and 2.6, whether it is significant, it is need to pay attention, or you can ignore it, or that difference is coming by chance. Is it okay?
Now I got the point. Yeah, yeah. Got it now.
Yeah. So this is what we were talking about. So this is a one way of formulating your null hypothesis. Suppose second way is the frequency.
Madam, it is not share. We cannot see.
Again, it is not visible.
No, it's visible. It's
Visible?
visible. Yeah, yeah.
Visible.
Okay.
You need to pin my screen, I think, ma'am.
Otherwise, also it's visible.
Okay.
Yeah,
So
I think pin is required. Yeah, true.
yeah. So I was writing the frequency distribution of candy colors is uniform. Uniform means, again, you can say there is no difference in the expected and the observed count, right?
Yes, ma'am.
Now, we will talk about the function which you need to use to perform the chi-square test. And the function is CHISQ dot test. And then you need to pass your vector, comma. This is the vector of, I think I am writing in detail. Usually you will not get this in detail form once you will find this function. But here I am elaborating you. In the first parameter, you need to pass the vector of observed frequency, right? And second will be the vector of probability. These two things necessarily you need to pass if you want to perform chi-square goodness of fit. Fine?
Ma'am, we can also define the vector over here in the function, or we
Yeah,
have
no
to.
problem. Inside also you can pass. It is not necessary that outside this function you need to define your vector. Not
Okay,
necessary.
okay,
Inside this also you can do this.
okay, ma'am.
I hope it is clear now.
Yes,
Yes, ma'am.
ma'am.
Yeah. So now here I have written this will be your
Observed.
way of writing the chi-square test. You can see what I did. I have written here chi-square dot test. First parameter will be your vector of observed frequency, which we have defined here. This is the color vector, right? So I have
Yeah.
passed here the color. Then I have passed the second vector of probability. So I have written P is equals to repeat 1 by 6 6 times. So probability, why I have written 1 by 6? Because how many categories are there of colors? 1, 2,
6
3,
categories.
6
5.
categories. Yeah.
1 by 6, or maybe in decimal point you can write 0.16 or 0.167. That is also fine. So 6 times I need to repeat because the length of both the vectors should be same here,
Same.
right?
Yeah.
Is it fine?
Yes, ma'am.
Also, if you want to write, do not want to use repeat function, in that case, what you can do, you can use the C function, and 6 times you need to write 1 by 6. Is it fine?
Okay. Yes, ma'am.
I hope it is fine. May I press on Control Enter?
Yes, ma'am.
Just a minute. Color. I have written C in a cap. Sorry. Yes. We got the answer in the console. You can see chi-squared value is 35.719
1,
for the degrees of freedom 5. P
5,
value is 1.38.
3, 6.
minus 0.6, right? So I think how many of you are very well versed with the p values, and you know how to interpret your hypothesis using the p value? Can anyone tell me?
If your calculated value is greater than 0.05, you are accepting your null hypothesis.
Okay. So I'm writing the thumb rule for acceptance and rejection of the null hypothesis. Thumb rule says if p is less than point or less than of your level of significance, so we will or
Reject.
we do not accept the null hypothesis, right? And vice versa, if p is greater than our level of significance, right? So we do not reject the null hypothesis. This is the thumb rule, right? So here we can see our case is what? Here, by default, this chi-square test function is giving you the value at 95% confidence level or 5% level of significance, right? So you can check the p-value is 1.386 e minus 0.06, which is less than 0.05, means we are not going to accept the null hypothesis. And that way you can conclude that there is a significance difference in the observed and expected frequencies of candy colors, or the frequency distribution is not uniform, right?
Yes, ma'am.
So this is the first way you have done this. Now I'm giving you the task here. First, you need to perform that, and then we will go for.
What one doubt? If P is greater than 0.5, then
In
do
that
not-
case, you will not. Yeah, you will accept your null hypothesis. Vice versa, both situations
Okay,
have
okay.
written here,
okay.
right? Now the exercise for you. So I think I have written this question here. What I'm doing, I'm copying and pasting it on chat, right? So I have given the question on chat. You can read the question, read the exercise, and please try to find the solution for it. Do I need to show you my R screen? I think question is available here also and on chat also. I hope you people are able to resolve the problem, solve it. Are you getting how to solve it? Or do you need any clue from my side? Yes. Any doubt, please ask me.
Some error is coming.
Okay. So, sir, can you share your screen? I have stopped
Yes.
shared mine.
Yes, ma'am. Yes.
Okay. Okay. I think, sir, you have not executed your line number 1.
Hmm.
Now you can read. I think you're getting the answer,
Yeah.
right?
P value is greater than 0.05.
Yes. In that
Yeah.
case, you will hold your null hypothesis.
Yeah, we will accept the null hypothesis.
We will hold.
Which means that, ma'am, interpretation of this will be
That there is no significant difference in observed and expected frequencies of the footfall, or
Okay.
footfall is uniform
okay on all 7 days.
on all 7 days or 6 days,
Thank you.
whatever are the working days.
Okay, ma'am.
Fine, may I proceed? I hope remaining has also performed this.
Yes, ma'am.
Done. We are going
But
for the
I don't get one thing, ma'am. Like, actually, we need to test it with actual data, right? Like, because the data that we are taking, assuming
this is
here,
the this is we have purposefully created these vectors and we are
Okay.
performing. I think
But
I have
then
shared the sheet
the
also
thumb rules that you have shared, yeah, that's good. That will
that
allow us
we
to
will
see.
use here in the second case now.
Yeah, yeah.
Similarly, you can take the data in files for goodness of it as well, and that we can perform, sir. Right? Is it fine?
Yes, ma'am.
Yes. So I think I only need to tell you how to bring the data in the R environment, that I'll tell you, right? So I think where I was here. I need to share.
Chancellor ma'am, would you also be sharing like how to actually like import data sets into our environment? Is that a part of the?
I think we have. I have shared our screen and that data set with you, sir. That we will import today.
Okay, fine.
Right.
You have shared where? I don't know.
I think in a WhatsApp group I shared with Yograj sir and Ajay sir both. Maybe they have shared the data in the WhatsApp group. You need to check your WhatsApp group.
Yeah, there's a CSV file. Yeah, it has been shared. Yeah, 2 files are there. Yeah, true.
Okay, so fine. I'll start. I think file is one. Maybe 2 persons have shared. I think I have shared with Ajay sir also, but sir has not seen the message, so I have shared with Yograj sir also. So maybe file will be same. You can check the
Yeah, it's the
name.
same file. Same file. Yeah. 221 bytes. Excel file. Same file. CSV file.
Yes.
Education doc honor.
Sorry.
Yes. Yes.
Yes. Now we will talk about independence of attributes. So it from name itself, it is quite clear. We want to see whether the attributes which we are considering, whether they are independent to each other or not. So that means in that case, we will be having two categorical variable, right? And we want to see whether the two categorical variable are independent to each other or not. So maybe I can write your null hypothesis will be there is no association between categorical variable 1 and categorical variable 2. Or other way around, I can say the null hypothesis will be the categorical variable 1 is independent of categorical variable. So these are the two possibilities of formulating your null hypothesis in case of chi-square chi-square independence of attributes, or chi-square association. Independence of association also generally we can call the second chi-square test, right? So now, if suppose I want to check this thing, right? Okay, I'm writing here exercise, right? I'm writing EXER. What is the problem? Capital X. Yes. So suppose I want to test. Just write what happened. Yeah. Suppose I want to write whether the smoking habit is independent of gender. This is a simple exercise. Here you can easily understand we are having the two attributes. First one is the smoking habit, and second one is the gender. We want to check whether the smoking habit is independent of gender or not, right? So in that case, what we will do, firstly, this first exercise I am taking like this, and second we will take off that particular data set. So we will see how to import it, and then we will work on that. Is it fine?
Yes, ma'am.
So here I am doing or creating the vectors, right? So first vector I am creating for a gender. So for gender, I need to use these. I need to create a string or character vector, right? So suppose I'm writing M, F, 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 M, F. Right? Okay, suppose I forgot how many, or I need to count that how many elements I have put inside the gender. I can check 7, right? So that way I need to create a second vector. The length should be 7, right? So that would be the smoking habit, right? So suppose it is coming as yes, yes. Suppose no, yes, no, no, and yes. 2, 4, 6, 7. Done? Fine.
Yes, ma'am.
Suppose I am creating a data frame, although not necessary, but still I am creating, suppose, a data frame using these two vectors. is, I think there is some problem. Object, okay. Capital S I used, sorry. Yes, fine. Now I can check my data. You can see it is converted into the data frame table form, right? I hope it is okay. Pace is okay. People are able to cope up.
Yes, ma'am.
May I proceed for the next step? Everyone, is it
Yes.
fine? Please say something.
When I'm running this, it is giving me error actually. This data frame,
Any problem are you getting, sir?
yeah, unexpected comma. Let me just check. Some error in creating, I suppose.
Okay. At the end, is it something at the end you have kept a comma?
Maybe I'll just check. Ma'am, you please continue.
Okay. So firstly, what we did, we have created two vectors. We have put
Yeah,
both
now
the-
it's okay. It's okay.
Okay,
Thank
fine, good. So now you have put both the vectors inside the data.frame function, and we created this particular data frame. But still the problem is we are unable to get a count. We are not having a count, right? And I need to tell you one concept here before going further. Maybe you have heard about contingency table, right? So it's a two-way table. Which gives count across categories of both the categorical variable, right? So I need to count. I need to make a simple table that for this particular combination means suppose the gender is female and suppose the smoking habit is saying yes. So in this context, how many of the female are saying yes for this and how many of female are saying no for it, right? So that way I need to create a contingency table first for performing the chi-square test for the independence of attributes category, right? So what I need to do, I need to make a table. So for making a table, you need to only use the function called table, and inside that you need to put the name of both the vectors or both the fields using or like this, right? Done. It is created. You can call it and you can see your table is like this. Fine.
you. Yes, ma'am.
Now we will perform chi-square test using the function chi-square dot test. Inside that you need to only pass this contingency table, and you can find we are getting the answer.
P value is 1.
Fine.
So how does it work? I'm actually.
Sorry.
How does this work? Like
Which-
why we have taken this table and
For contingency table, I told you, na, we need to have data in this form. We need to have the counts. In the previous way, when we have created this data
so
frame,
not
we
the
are
values,
the
okay,
counts.
not the values. Yeah, we need to have.
Yeah, so you need to create a contingency table, and that way it will clearly it will clearly saying us that in for frequency, if I talk about female and the not category, so it is two. That the two females are saying they are or their smoking habits are or they are not taking the smoke.
Okay.
Two. And two females are saying yes for this. Male are 1 in number and 2 in yes and yes category, 1 in no category and 2 in yes category. So this count you need to have to perform the chi-square test. So that is why you need to create a table in case of chi-square goodness independence of attributes, right?
Right.
Fine. So I hope till here everyone is okay. You can, I think, interpret your output now. Output value, you can see p value is greater than 1, which is very large, right? So you will accept or hold your null hypothesis. And you will conclude that the smoking habit is independent of gender. Means there is no impact of gender on the smoking habit, right? No association.
How do we conclude this? Like,
You need to see the p value, sir,
okay,
right? P value is greater than 0.05.
0.05. Okay.
So
The
that
same
will-
thing that we did. Yeah.
Yeah, so that way you hold your null hypothesis. You know, we are holding it. So that way we are concluding that the smoking habit is independent of gender, or there is no association between smoking habit and gender. Fine, sir.
Yes, ma'am. Right.
Yeah.
Thanks.
Now, I think I have given a file to everyone. I think you people have downloaded it, right? Now, what you need to do, the way I'm doing, you need to do that. I hope my, just a minute. I have shared a folder. Means on my screen, you can see a folder. Is it visible to everyone? Is it fine?
Yes, ma'am.
So now what you need to do, you need to locate your file where that file is available in your desktop or in your laptops, right? My file is available here. What I did, I came here, I did a right click on this, right?
Right, ma'am.
You need to go to the properties. Fine.
Yes,
Under
ma'am.
the location, you need to copy the location of your file.
Right.
Control C. Done?
Yeah. ma'am.
Please once again repeat, not clear.
Okay. I said, sir, you need to locate your file on your desktop or on your laptops, right? Maybe
Yes,
suppose your file will be on download or somewhere.
Yeah.
I don't know where you have shifted it. If it is
Yes.
in download, you can go on download. You can locate your file. And once you have located it, do a right click on your file. Then go to the properties like this, right?
Okay.
This box is coming. It is showing you the location of your file. You need to copy the location of your file. Control C. Done?
Okay.
I hope done.
Yes,
May I
ma'am.
pause this? Yes. Now I'm coming back to my R script. Here you need to use a function called setwd. Set working directory you need to use here. And in the double quotation, you need to pass the location of your file, right? And then you need to convert, just a minute, you need to convert these single backward slashes into the double backward slashes like this. Fine.
Yeah. Do we need to? I think we can just write the path, or do we need to write the file name also? Only the path, I suppose.
After that, we will read this file and then we will
Yeah.
use
Yeah.
that.
It will be picking up the file from that.
Yes, from there.
Okay.
So I am only setting my working directory from where I need to pick my file.
Right.
So I think I can press Control Enter. I hope no one is getting any error like mine.
Yes, ma'am.
Now you need to use a function called read.csv.
Okay.
Right? Now you can come on your file and rather than typing, I suggest you go and copy the name of your file and in the double quotation or in the single quotation, paste the name of your file and after that write .csv. With extension, you need to pass the name. Fine?
Yes, ma'am. It has loaded some values table. Yeah.
The file is loaded like this,
Yeah.
right?
ID, gender, pet, education. Yeah. Got it.
Very good. So now I think I'm storing my file in some variable name. I need to give what name I can give. Education or something ed I'm using, pressing Control Enter. Now it is stored in the this particular variable name, right? Done. Now,
Yes, ma'am.
as you can see, we are having the three different categorical variables available: gender, pet ownership, education, right? Now, if I want to perform the or if I want to check whether the pet ownership is independent of gender or not, that means I need to work on gender and pet ownership. Fine.
Yeah.
So
Yes,
here
ma'am.
I'll write my hypothesis and what it will be. There is no association between pet ownership and gender. Or other way around, I can say
Pet
pet
ownership is
ownership.
independent of.
Very correct. Right? These are the two different association. Oh. Fine.
Yes, ma'am.
Right. Now, further, we need to perform chi-square, right? So I'm writing chi-square dot because we are having the data in this form. So I'm just trying whether we can directly use. I need to check. I haven't performed previously like this. I'm checking this whether we can do it like this or not.
Yeah, we can do it as showing the attributes.
No error we are getting.
Yeah.
We have got the answer. Yes. Right. So that way you can see we are having the chi-square value as 0.879, degrees of freedom is 1, p value is 0.3484, which is greater than 0.05, right? So sorry. So you can write here p is greater than 0.05. So we are going to or do not
Approve.
reject the null hypothesis, right? So conclusion will be there is no association between pet ownership and gender. Done?
Yes, ma'am.
Okay. So can you people perform for the remaining two, or pet ownership and education? Can education do education play any role in deciding the pet ownership or not? So can you perform the next one by your own? Please do that and tell me the answer. What is the accept, whether you are accepting or rejecting your null hypothesis?
It comes out as 0.1924.
Okay. It's a chi-square value, sir?
Yes, ma'am.
And what is
Between the, yeah, it is greater than 0.05. So,
means p value is greater than 0.05?
yeah, it comes out at 0.1924. Yeah.
Okay, great. So that means again you are holding your null hypothesis, right?
Yes.
Good. Fine, it is okay. One exercise I am writing here for you. Sir, if you have performed, you please try this.
Okay. Like if we hold our hypothesis, ma'am, then we another way of saying it would be that there is that this education is independent of being a pet owner, right?
Sorry, education is?
Education is independent of being a pet owner. There is no correlation.
Yeah, But I think rather than saying this way, you need to say in terms of pet ownership, because pet ownership is dependent upon education or maybe on gender. Gender and education are the independent variables, right?
Okay. Yeah.
So I think I have written a problem for you, sir.
So like I need to assume data.
Yes, yes. In that
That's
case,
a tough. Yeah, I'll do that, but that's a tough ask.
okay.
I'll work with some data sets instead. I've got the idea now.
Okay, fine.
Can you scroll down your screen? Just I want the command line. Chi-square command line.
This one, sir, line number 581.
It is not visible to me, ma'am. 581. Please scroll down.
Scroll down.
I am able to see 582.
Now,
No.
okay. Anyone else who can see the line number 581?
Yeah, we can see 581 and 582, 83, 84, 85. All lines are visible.
Okay, Santosh, sir, what is the problem?
I don't know.
Not visible.
No, not visible.
Uh, then how can I help you? Can I copy the syntax there in a
Yeah.
chat?
Yes, ma'am. Yes, ma'am.
Okay. This is the syntax I have shared with you, sir. You can check. Fine.
This one, ma'am. The line where we have stored this value in ED.
Okay, that line you want to see, 577.
Yeah, ED is equal to read.csv,
Now
and
you
in
can,
the bracket.
fine, sir. Are you able to get it or I need to copy it?
Yeah, ma'am. Please copy.
Okay. And paste also, right? Okay. Paste it. I think it is available, sir, there on a chat. I hope you received it. Able to perform, Santosh, sir?
Yes. Yes.
Okay. What about the remaining friends? Geeta ma'am, are you there today? Yes. Soumya ma'am, Sajja ma'am performed.
Yes, yes, I am there, but my things is not okay, na man.
Sorry?
Means our studio is not working.
It's still not working. Ma'am.
Means I have downloaded.
Okay. What problem you are
Ma'am, for me, I downloaded RStudio 3.2 version. No, sorry, R 3.2 version. But RStudio, I think there is only one version, but they say it's not compatible with the Windows 7.
Okay.
So RStudio, I don't think there is.
So you can work on R also, ma'am.
We can work, is it?
Yes, yes, no problem in that.
Oh, then I will do, ma'am.
Yes. Geeta ma'am, what about your in your case? Your case is similar like the Soumya ma'am's?
I am sharing with you.
Okay, just a minute. I'm stop sharing my screen. Okay, you can share, ma'am. I have stopped share. Ma'am, you need to, can you see a brush?
Brush.
Brush sign, can you see? Opposite R 4.3.3. On a same ribbon, you can see there is a bar. Oh, sorry, there is a brush. Can you see? Ribbon R. I don't know, where is your R? When downward in the taskbar, you need to click that.
Means where it is, ma'am?
Ma'am, can you see console, terminal, everything is written there. Can you see console in the same
Terminal and
right.
background job.
Yes, on a same ribbon you need to go, and you can see there are two squares, double squares. You can see small squares were visible there.
Yes, right corner.
Click on that.
I have to click it.
Yes.
Yes. Now console. Okay. I
Done?
don't know. I have missed some classes. Means first class, then second class, first class, next class. Echoing because phone and
Have you joined from the two devices?
yes.
It is
Now I
because of
stop.
that.
I
Yes,
am
you
put off.
offer one device. Yes, one device. Yes. Now it is fine. So this is available now. You can work.
Yes, ma'am.
Okay, fine.
Now I am off sharing.
Yes. So I hope it is done.
Yes, ma'am.
Yes. So I think this was the agenda of the day I discussed. If you are having any queries, now platform is open for the discussion. You can please ask.
We need to practice with some data sets. Otherwise, the session was quite
I
difficult.
try to do one thing. Tomorrow I'll give you some other data set, right? Although in that data set we will talk about the t-test, but using that data set you can work on some other variables also. There are some other variables also available, sir. Using that particular data sheet, you can work on the chi-score also, right?
Okay, ma'am. Right.
Whatever is the sample size, we can do it, right? If it is 100 or
No
500 also, same way.
No problem.
Okay.
Tomorrow I'll give you a big data set for T. Fine?
Right. Right, ma'am.
Okay, fine. Anything else? Any other query you are having?
No, ma'am.
My data is coming on different
On
here.
different?
On
You
a
can
different
share.
means yeah.
You can share.
Okay.
Sir, think you need to, this is the way the data is shown to you. Your data is shown in the script. You need to
Okay.
click on the previous one, upper side. I can tell you.
File?
No, not that. You can need to see there are two tabs now. You need to go in the previous tab. That was, I think that is visible with the red color.
That is the practice.r.
Yes, I think that is the name.
Yeah, this is the one. Yeah.
Sometimes it happens, it shows your data in the next script.
So from here, how I will open the data which is stored in the desktop?
Sir, I think it is already there. You have just seen that was available there. Next R. It was available there, no problem.
So he wants to load that.
You can store your data now. Now what you can do, sir, write here any name of your variable. What that ZW do you have performed previously?
What were? No, no.
No.
So I think you have missed, sir. Here I am telling you, please type, right? Set SETWD. W you need to write, it will come. Yes. Now open a bracket. Okay, I think you can hear me. Open a bracket. The round bracket you need to open. Santosh sir, are you there?
Yeah.
Yes,
he's done
ma'am.
Now inside this, in the double quotation, you need to give the location of your file. So firstly, you
Yeah.
need to
Yes, ma'am.
get that location, sir.
it. Go to desktop, sir.
That
Your file is there in on desktop or in download.
desktop, on desktop.
So go to your desktop.
Okay.
Right click on the file.
Okay. Properties.
Properties. From location, you need to copy the location of the file.
Okay.
Copied.
Yeah, copied.
Now paste your location here under this double quotation. Right.
Great.
Now execute this. Run this. Run this line.
Without writing chi-square.
Yes, nothing you need to write, sir. Firstly, we are setting up our working directory from where we need to pick a file. I think you haven't executed. Executed. Error is coming.
Yeah.
You need to put the double slashes.
Yeah, double slash you need to use. Double
Where?
backward slash, right? The same slash you need to put one more time. Upper the enter key, I think you can find it. Before admin also and before desktop also. Now control enter. Now use any variable name, whatever you want. The way I use ed, you can use any name, whatever your wish is. Okay. Now assignments and equals and whatever you want to put.
Equal to. And then read.csv.
Read.csv. Once you will write read dot, it will show you the functions. Yes. The first one you need to pick read.csv. Inside this double quotation, copy the name of your file. So rather than typing, I'll suggest to avoid the errors and all, you can copy your name, file name. That will be much better. Paste. And after that, put the extension of the file, that .csv.
Yeah, remove that part. Yeah.
Now control enter. Now
SKS.
yes.
SKS and enter.
SKS you can, yes, to see your data. Data is available, right? Now perform the chi-square. Dollar,
Gender.
comma, pet owner.
You can press
not
enter
type,
here. You
not
can
type.
press enter here.
Better, huh? Better to take from this, yes, prompt.
Yeah.
Control enter or run. Was gender in uppercase?
I think pet owner is in uppercase.
There is some problem. I think gender, I need to check in my file. Gender was in uppercase or what? I think gender was there in uppercase, sir. You need to check.
No, gender is in sentence
G.
case, G capital and then
He was
you
the capital, yes.
yeah, G capital, and in pet owner also P
Pet owner
capital and
P
O
capital.
capital. O capital.
Yes, it was a sentence case, correct.
P capital, sir.
And O capital. P and O, yeah. Now to run.
The case sensitive language, right, sir?
Yeah.
You got it.
Great. Great.
Okay, thank you.
Fine, sir?
Thank you, ma'am. Yes, fine.
Yes. I hope everyone is able to perform, right?
Yes, ma'am.
Yes. Yes.
Good, Geeta, ma'am. I think you have done along with sir, because you have first time
No,
now.
I didn't do. I observed.
I know
I
you are
observed
observing,
only.
but ma'am, performing is a different thing.
I know because means today I am able to now. I will do.
That's great. That's great. Very good. I think we need to salute your spirit. That's great.
Yeah, very persevering.
Yes. So I think this is all for the day from my side. If any queries, I am waiting for the queries. If not, we will go for a pic.
Big time.
Yes, it's a picture time. No questions? I can see Soumya ma'am, Ajay sir. Geeta ma'am, are you switching on your camera?
Ma'am, one question. When we write
ma'am.
this,
No, ma'am.
when we write this research article, so how to copy and paste all these things in the MS Word or something like
That we will see tomorrow,
that? Okay, ma'am. Okay.
right?
Okay.
Fine. So, ma'am, are you switching on your cameras or may I need to capture it?
Madam, please capture. I am not opening.
Okay, no problem, no issues. I think there is a problem. Just a minute. I have so much sweat on my hand.
I told you we should come to Amritsar. It's still chill out here. Chilly weather here.
Okay. My mother is there in Sagar. Maybe you have heard about Sagar, MP.
Yeah, that's in MP, I know.
Yeah. So there is also a very cold weather. She's
Yeah,
saying.
MP, UP, all this stays cold for a longer period of time.
Yes.
But I would not recommend to come in Kerala because it's
Oh, it must be very, very hot.
Beautiful, sir. No?
yeah, beautiful. The sea is very good, but only two weathers are there: summer and rainy season. No
Okay.
winter.
No
Okay.
winter.
Okay.
So,
So you need
Santosh
to
sir,
come
for
down here.
winters you can
Please come down here.
come to North India.
Yes.
Yeah.
Come down here.
In winter, I go to my home, sir. Basically, I am from Lucknow, working in Kerala.
Okay.
Oh, Lucknow is a
No
great
issue,
place.
sir. You can plan your visit for Indore also. No problem.
Oh,
We will welcome you.
Okay, ma'am. Okay, sure. Thank you.
Yeah. So this is all for the day from my side. Thank you, everyone. Good night. Take care.
Thank
We
you,
will
ma'am.
meet tomorrow.
Thank you, ma'am. Good night.
Good night, everyone. Take care. Bye.
Thank you, ma'am.
Thank you. Thank you, everyone. Yogaraj sir, we are done. Are you there?